So we are going to have 3 routers. And between these 3 router, we have a point-to-point. Between router 1, we have a serial link. Serial links are nothing but point-to-point links. 0 is the 0th port, serial port on this router, and it is 0th port. 2 or 3. And we got a switch here. And we have somewhere around you can say 10 computers. Plus, we need to give an IP address here on Ethernet 0 and here, which means in total we need 12 IP address. 10 for the PC, 1 IP address in the same subnet for this port, another one for this port. So we need totally 12 IP address here. And we got another LAN, means another switch. Switch is a LAN device, layer 2 device. We have, let's say, 50 PC connected to this LAN. And we got another LAN to which we gave, let's say, 100 PC connected. And finally, we got another LAN where we have somewhere around 2,500 PCs. And the network that you're supposed to use is 172.0.0.0. All right, and then you do subnetting, starting with a small number. I hope you remember those things. Now, in that subnet that you get here for this point-to-point, give the first IP over here and last IP here. And for this computer, you give the first IP here. In the subnet that you derive for this 50 PC, you will also have a last IP. Put the last IP here. Likewise, first IP here. On this Ethernet 1 port, last IP. First IP here. And you give second last IP here and last IP here. You understand, right? Second last. Okay, see. 1, 2, 9. 9 is the last one. Second last is 8. Okay. So second last address on the router 2 side. And last is on the router 3 Ethernet 0. And here we got another LAN with 2,500 PC. And you give the first IP here and the last IP here. Okay. So you may start. Okay, சொல்லுங்க answer சொல்லுங்க. Slash. How many bits you have kept for the host? Just 2 bits, right? So, so if you keep 2 bits out of 32, the balance is 30. That is what we use for network, isn't it? Now, what will be the IP address for this port, the last IP? Hmm? என்ன ஆச்சு? Okay, I will do this. I'll do this. You try to do another one. Listen, how many IP addresses you want here when it is point to point? Please answer. How many addresses you want when it is point to point? Point to point, Priya. This is one point. This is another point. How many addresses you want for each point? One address. So two address. So do subnetting based on that info. 172.0. This is already masked. Now for two address, you need only 2 bits, correct? So from here onward, from this bit onwards, you are giving, which means /30. 255 minus, sorry, 32 minus this 2 is /30. And the first network will be 172.0.0.0, 172.0.0. What next? 4, which means what will be the last for this one? I know one is this, the first one is this. What will be the last on the subnet and what will be the broadcast? Hmm. 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 ஆமா. Okay, last IP? எப்படி 64? Okay, now tell me, what is the last IP? That's all. See, you know it, but I don't know why you got confused. You know it. All right. அப்படியா நீங்க எழுதியிருப்பீங்களே, that is what I want you to present it. அதை பார்த்து படிப்பீங்கன்னு பார்த்தேன். You would have done one by one only, no? Okay, next what you did. So the network is 172.0.0.0/30. This is over. This portion is over. Now next you should have done for 10, not 50. அடுத்த பெருசு இது 2 ஐபி அட்ரஸ் தான் இங்க. நெக்ஸ்ட் பிக்கெஸ்ட்னா இது தானே, 50க்கு போக கூடாது. So for 10 PC, how many bits you need? So you need 4 bits, isn't it? Correct. So this will be the first network. Second network will be 16. Correct? So first network, last IP will be .14. Broadcast will be .15. Correct? But we are not going to use this because some of the address we have already consumed. So the next one is what you are going to use here. And 0 dot 32 is 31, here 30. So this is going to be .30, correct? Last one. This is broadcast. Last one is 30. Second last will be .29, correct? The network is 172.0.0.16//28. Am I right? 32 minus 4. 32 minus 4, 28. Okay, what is the first IP in this? 172 dot correct. இந்த நெட்வொர்க்ல ஃபர்ஸ்ட் ஐபி என்ன இதுதான் நம்ம இந்த நெட்வொர்க் கொடுத்துருக்கோம். வெரி குட். தட்ஸ் ஆல். கன்ஃபியூஷனே ஒரு ஃபர்ஸ்ட்னா டாட் ஒன்னு தான் இருக்கணும்னு அவசியம் கிடையாது. ஓகே, நெக்ஸ்ட் we have finished now 2 IP, 10 IP requirement. Now let's move on to the 50 IP requirement. 50 IP. Okay, so 50 IP, how many bits you need? Very nice. 63 வருது. Okay, so you need these many bits. Correct. So the first network is 00, second network is 64, 128. Again, we are not going to use this one only because we have used up to 30, which is in the very first one only it falls. So we use the second one now. That's going to be the network 172.0.0.64/26. Okay. Now what will be the first IP in this? 65. What will be the broadcast? 120. 128 is next network. Okay, what is the last one? Exactly. Now let's fill it. This is the network. The first IP is .65, and then the last IP is .126. 7 is broadcast. That's all. Now we move on to 100 PC. So for 100 IP address, you need 7 bits, correct? So 7-bit means this you need, and rest all we give for networking. What will be the new mask? /25. So 172.0.0.25 we are not going to use, and the next one is 128. Yeah, 128. We'll be using this one. 128, 172.0.1.0. So the broadcast is going to be what? In this 0.255, because the next one is 1.0, no? Okay, the first IP is .129. Last IP is 0.254. Okay, that's what you're going to write here. Let's write here 172.0.0.254. Okay, good. Okay, the network is 172.0.0.128/25. All right, because the mask is different, 25, 28, 30, 26. That's why we call it as VLSM, variable length subnet mask, right? VLSM. So now one more big one, 2500 IP address I want. So how many bits we need? அப்படி போகாது, அப்படிலாம் போகாது. See, இதுல 255 போக I appreciate all 8-bit. And if this is 128, what is this one? 256. What is this one? 511, 512. Correct? Just double it. What is this one? 1024. And what is this one? 2048. Now, what is the question here? We need 2000 fire. So now go to the next one. 4192, correct? 4196. Is it 4196? Yeah, 96. 8 to 16, correct. Now, if I take all these beats, how much I'll get, 4195, because the next one is 96. If I take up to here, I'll get, but if I take only these beats, I'll get only 2047. But what we need is more than 2047. Yeah? Okay, do you follow me? Now, we need to take this many bits. We need to take these many bits for host. So right from here in the third octet, we are giving for networking. What is the value here? No. What is the value of this place? When it is divided as octet, what is the value of this place? Priya, face value. 1, 2, 4, 8, 16. 16. So in the third octet, we need to increment by 16. 172.0.0.0. 172.0.16.0. 16 in the second octet. You got it, right? Okay, next 172.0.32.0. Now, what is the mask? 16 plus 4, which is 20, correct? 20 is the mask. And we are not going to use this because some addresses are already consumed. We are going to use this one. So the network for this is, let me remove all this mess. Okay. Now I'll write down here. For the network for this one is 172.0.0.0/20. And the first IP will be 172.0.16.1. 16.1, right? 16.1, not 17. See, the fourth octet is 0. Okay, what is the last one? 31.255 is the broadcast. 31.254 is the last one. So let me write it down here. 31.254 is the last one. Okay, you may copy this, but again, I am going to give you another one because I helped you to finish this. Can I give you another one? You're happy or not if I give you another one? Okay, then copy this. 160 computers need 160 IP, plus the router needs another IP from the same subnet, so 161 IP address. Let me write down here 161 total number of IPs needed. And likewise here we have 200 PCs, which means you need 201 IPs. It's 200 plus 1. And here it is 300 PC. First here and last year, which means you need 301 IPs. 301 IPs. Right, and we have another where you got only 10 PCs. So totally you need 11 PCs. 11 IP address, 11 IPs. And the network that you are going to use is 10.0.0.0. Okay, this is your homework. Can you do this? Okay, great. This is our next chapter. Understanding Cisco's operating system that runs on the router called iOS. iOS is the name of the operating system. Like we have Windows, Linux. The routers of Cisco runs an operating system. The name is iOS, Internet Working Operating System. iOS. I want to show you how it will look like. What you are seeing is an operating system getting loaded. And what does that CLI stands for? Command line interface. Command line interface. This is an operating system, and version is 16.6.4, and it is located, saved in a place called flash memory. This is the memory in which the operating system is kept. Now, I did not do anything. I just turned on the router, and we saw automatically it got loaded with the operating system. Look at this. This is the exact name of the operating system. ISR 4300 Universal K9 16.6.4 SPA.bin. Bin is the file extension for all operating system in Cisco. Like we have document, no? .doc, .xml, .ppt. We have, right, file extension. Likewise, the operating system of the router has got this bin extension. Bin is image format. The file is in the format of image. And that image is located where? In the flash memory. And this is the size of the flash memory. Let me show you inside the flash memory. You don't need to worry about the commands that I'm going to type here. Just only see what I'm showing you. Show flash. Look at this. The same operating system which you saw above, you can see here. Inside the flash, it is kept. And this is the file name of the operating system. It's the same file that you saw on top that got loaded. See, it got decompressed. Because it is in an image format, the operating system need to get decompressed into multiple files. It's a single file initially in the flash memory. That's what you see here. It's a single file. But when you turn on the router, that single image get decompressed into many files. That's what happening here. Decompression happens here. And then it loads like this. And you are able to see the operating system now. When I type show running configuration, this is the skeleton of the operating system. See, this operating system has got some interfaces, interface gig 000, interface gig 001. There is no IP address configured. Yes. You should not get panicked by seeing all this. You're going to go piece by piece, step by step. I'm just showing you how an operating system of a Cisco router looks like. It's command line. It is not a GUI based. It is not a graphical user interface. It's command line. Like we used to do programming in shell prompt, like C, C++, Java, Python. We do it here, but it's not difficult like programming here. This is user-friendly commands. Show running config, show me interface brief, show IP interface brief. It's very friendly commands, not tough like a programmer's language. Easy, all simple English words. In order to see all the interfaces in a brief manner, we type show IP interface brief. All right, so no need to memorize anything here. Now, our topic is about this iOS. Internet operating system. One point you already learned. It's an image located in flash memory. Now, when we turn on the router, the control goes to flash memory. Now, this is the place where you have the .bin file, the operating system. Now, this operating system is copied. I'm saying a word, copied, which means that bin file is still there. Only a copy of it is taken, and it get decompressed. After decompression, it got loaded into DRAM. This is flash, this is DRAM. DRAM stands for dynamic random access memory. DRAM, dynamic random access memory. Now, this DRAM is a volatile. You see, here it was very clearly written also, volatile memory. In the introduction page, when we load the operating system, you see how nicely it says non-volatile, and then this is volatile physical memory, this is DRAM. This DRAM is volatile, meaning what is volatile? Do you know what is volatile? DRAM is volatile. What does that mean? Have any idea what is volatile? Sorry, again? You're close. See, volatile here means, as you said, evaporates. Very nice. As you said, it will disappear. When the power goes off, all the configuration that is residing in this memory will disappear. Very nicely you said, no? Disappear, evaporate, disappear, volatile. Good. Volatile means it'll go away. It'll go away when the power goes off. So whatever is in DRAM need to be pushed to a non-volatile memory. Yes, we have another memory here, NVRAM. Non-volatile memory, non-volatile random access memory. That is what you saw here saying non-volatile memory is of this size. So we are seeing three type of locations. One is flash, where the operating system in a bin format is residing. The second one is NVRAM, which is non-volatile. That's what it means, non-volatile, NV. And we have DRAM. Now you see, I want to repeat the story from the beginning. We turn on the router, the control goes to flash. In flash, what do we have is a bin file. I showed you that. This is the size of a flash memory in which this much is being consumed by the operating system. The size of this operating system is this big. So it is in bytes, this much bytes it has consumed, and this much is still available, free, empty. Okay, now what is next is now as soon as I turn on, this operating system is not disturbed. I want to repeat again. This bin file, it will never be altered. Just a copy is taken. A copy of the image, the copy of the file is taken. And then get loaded to DRAM. But while coming to DRAM, it will just have a visit here. Is anything in NVRAM? Nothing. Why nothing? Because we have just opened the router first time. We have never saved any configuration. If you save some configuration, then you will have something here to load. Yesterday's configuration, something which you did earlier, will be moved to non-volatile, so that when you turn off the router, the configuration will still be there for your next day. But in the beginning days, when it is just out of box, this NVRAM will be empty, nothing in it. So only the image that got decompressed is loaded here to DRAM. That is what you saw here. Up to here, up to this level. It was asking one question initially. Let me do one thing. I'll take a fresh router. I'll delete this. I'll take a fresh router now. You see, it is decompressing. And it will stop after showing you a question. Right now, it is still decompressing. Okay. The whole operating system got decompressed and loaded into DRAM. But on the way, I told you it will go visit the NVRAM because NVRAM is empty. The router understood that this is a fresh router. That is why it is asking you this question. Would you like to enter the initial configuration using a dialog? I want to repeat again what I said. Only when NVRAM is empty, nothing inside it. You will get this question. If you don't get this question, what does that mean? Something is already saved in NVRAM. For example, I'll open a project which is already done in some other class. Now, when I open this router, you won't get that question because, see, it didn't ask me any question. It just loaded and it came and halted here in a prompt. This prompt was not there in that previous case. Let us go back. New project. This time it is going to ask you a question because there is nothing in NVRAM, nothing saved. It's a fresh route. You see again? Only when the router is empty without any configuration done before. Sometimes you might have done configuration, but you would have forgotten to save it. So if there is nothing to load while loading, I told you, operating system will not be disturbed. So whatever you configure will not get appended here. Your operating system will not get altered with your configuration. Whatever you configure is here, and when you save it, it goes here. So your configuration alone resides here. Every time you turn on the router, the operating system is copied and decompressed. While coming on the way, it loads all your previous day configuration and comes and shows you here. But if there is nothing to show, only then you will get this question. Because router knows that there is not even an initial configuration in this router. Now, what should I say here? Should I say yes or no? We will always say no. Why? Because we are going to learn how to configure. So we no need to go through a dialogue-based wizard. We no need a dialogue-based. We no need someone to ask question and then we answer. We will straight away go and put the commands wherever we want. We don't want some dialogue-based configuration. Then who need to say yes? Only those people who have no knowledge on commands, but still, they have a router, but they never gone through a training like CCNA. They don't know anything about router, but they have purchased a router. So for them, a dialogue-based configuration is needed. Again, they cannot do big advanced configuration like what we are going to do. They can only do initial configuration with that. When you say yes, only limited configurations you will be able to do. So we will always say no here so that we can, as an expert, go and do whatever we want, wherever we want, directly without someone asking whether to put this or put that. For example, you see, I say enable config T, and I'm going to give a name for this router. I don't like this default name router. I want to name it as host name Priya underscore Pavitra. See, the name is changed. And I would like to give a banner like this. Welcome to the world of networking. Banner Message of the day. Hey, banner. Okay, login time. Let's put message of the day. Message of the day. I can even copy and paste. All right. And now you see, I have to save this. I'm saying copy running configuration to started. Don't mind about these commands. I'm going to explain you uh, every command and make it easy. I'm just showing you how the command line interface looks. We are just introduction to iOS, this first topic. An introduction I'm giving. Now you see, I off this router. This is the on button off, but I off the router. You see, it must be powered on. So now let me power on. Because I have saved, I will get those configuration which I already done. This time it won't ask me any question whether to configure initial configuration using dialog or not. No questions will be asked like that. It will just show me the banner. You see the banner. Welcome to the world of networking. And you see the name that we set. So what happened actually here is the control went to flash, loaded the operating system, went to NVRAM, loaded my previous configuration, and put everything together in DRAM. That's what I'm able to see here. Not just the operating system, I also see the previous configuration. Operating system came from flash. My previous configuration came from NVRAM. So this is to tell us that the operating system never gets altered. And the operating system is in image format. Where is that operating system located, Pavitra? Pavitra, are you there? Where is the operating system located? Priya? Flash. Show flash. You see? You can see that here. All right. Fine then.